In this video, we'll be looking at some things for our transformation project. First, let me direct you to Haiku. You can see on the 7th, that's when it's due, it says PBL. If you click on that, you'll get our project description document. You've all seen that. It describes our project and has our very limited number of qualifications, things that we need to hit. All right. What I've recently added is transformation project sample courses. If you click on that, what you're going to get is a document that gives you some potential panels that you can use as obstacle courses. And there's over 20 of them in here. You can use these panels for half of yours. That is, at least half of yours must be your own creation, but half could be the ones that I have here. Note, one nice thing about these obstacle courses is you can change the size of your obstacles. Like this little pasted in lightning bolt here, you can click on it and you could decrease the size of it if you want to make it a little bit easier to navigate. All right, I'm going to use panel 2 here as an example of what you'll be doing. Okay. All right, so I'm in panel 2, and I have my superhero as Triangle Man here. All right, hopefully you are a little more artistic than me, but if not, you can certainly use some small geometric figure. But the key is we need 3 distinct points, and here I have my 3 distinct points. You don't have to necessarily label them, but they need to be clear to work on your transformation. Now, we must have at least 2 transformations, and I'm going to say not more than 4 for each panel. So I'm going to get Triangle Man from where he's starting down here to the exit. I want to make my description in words and use an algebraic transformation as well. For instance, I'd like to get Triangle Man from where he is right now down here. Well, intermediate movement, I may move him down some and then left some. Well, that would be a translation. Down some amount and left some amount. How much? Well, let me see. Starting at this point, I could go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then I might move to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, my first movement, Triangle Man, my superhero, will slide, and we know slide is translate. "13 units down and 10 units left." All right, that's my verbal description. Now I need an algebraic transformation. So what we have here is our XY, our old XY, that is our pre-image, will be transformed to our image. Well, if I'm going 13 down and 10 to the left, well, we talk about our X movement first. That 10 units left would be an X subtract 10, and our 13 units down would be a Y minus 13. So 10 left and 13 down would be X subtract 10 and Y subtract 13. Let's look at each one of our points accordingly. So this point here is 2, 14. This point here, same Y, X 1, 2, 3 more, so it would be 5, 14. And that X would be 4, 15, 16. So transforming all these points, X minus 10, 2 minus 10 would be minus 8, 14 minus 13 would be 1. So this point would move to negative 8, 1. Negative 8, 1 is right here. And hopefully we'll see that that corresponds with my 13 down, 10 left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, what do you know? We got it right. So I'm just for giggles, I'm going to label this one A, and then clearly this one's A prime. You don't have to do this, but just make sure that I can see how your points transformed. And so we know that likewise these next two will be thusly transformed. Notice that the y value was the same. The y value was the same in the pre-image, and it's the same in the image. All right, so here is Triangle Man after his first transformation. Okay. All right. Now we want to get him down here. Well, we could do another slide, another translation. All right. Let's try to mix it up. Let's try to not use the same transformation consecutive times. The original rubric said you cannot. I'm okay with you doing it, but let's see if we can. We want to mix up what we're doing. We want to try to get in all of our rigid transformations, which are our translate, our rotate, and our reflection. So how can I get Triangle Man a little bit further? Well, let me flip him. I'm going to flip him across the x-axis. All right, so on next move, Triangle Man will show off his agility. Triangle Man will flip across this line. Maybe you might draw a fence in here or a wall or something, but clearly it's our x-axis. Triangle Man will flip across the x-axis. All right, so if he flips across the x-axis, all of the points, they're this far away from the x-axis, they will be that far on the other side. So here's my A prime, my new point. I'm going to call this one A double prime. 1 unit above, it's 1 unit below. Notice the key with our reflection, it's a perpendicular distance. 1 unit perpendicular, 1 unit perpendicular below. That's our pre-image. Here is our image. All right, this point, 1 unit here, 1 unit here. This point, 1, 2, 3 units. So 1, 2, 3 units. All right, so here's my new triangle. Now I'm going to have the challenge of drawing Triangle Man upside down. Boom, boom, smiley face. All right. So there's Triangle Man flipped across the x-axis. Okay, so consider what this transformation will look like. Our pre-image was these points. All right, I didn't label my last one here. 4 minus 10 would be a -6. 16 minus 13 would be a 3. Let's hope that this point was, yep, -6, 3. All right, so these are my new pre-images. All right, so negative. So my pre-image, I'm going to call it again XY. My new pre-images are these previous images. So we have -8, 1, -5, 1, and -6, 3. Let's just consider what's happening here to the points when we flip them over the x-axis. Well, this was -8, +1. Now it's -8, -1. So this new one becomes -8, -1. So what it appears has happened is the x value remained the same, but the y value became the opposite sign. Does that make sense? Well, yeah, it does, because when we flip across our x-axis, what we're changing is the y value. The x value did not change. We really made a vertical movement here, so it made sense that our x remained the same. The y became opposite sign. let's look at this point here. This point is negative 5, 1, and it becomes negative 5, negative 1. So negative 5, 1 becomes negative 5, negative 1. So hopefully you see our x's remain the same. So x maps to x, and our y changed signs from positive 1 to negative 1. So we want the multiplicative, we want the additive inverse. So y becomes negative y. It's just saying whatever y was, it's now opposite that. So clearly our final point is negative 6, negative 3. Okay, now I need to get him all the way down here. Well, I hope that you can see I could do another translation. I could slide him all the way on out. I'm going to leave that to you to figure out, but this is the general idea. You will need to have your superhero in at least 3 distinct points. You will need to describe a transformation in words. And here is what I'm keying on. We know a slide's a translate. Let's make sure we're using our good math vocabulary. I didn't hear. We know a flip is a reflection. So let's get that in there. Again, we're talking about our rigid transformations. Transformation just means change. And our rigid transformations are our translation, a slide. A reflection is a flip, and a rotation is a spin. And another term for our rigid transformation is an isometry, same measure. We're not changing the size, we're just changing the position. Okay, so have your superhero with 3 distinct points. Hopefully you get a little more artistic than me. You want to move him around our obstacles. In this case, the circle, the lightning, this pentagon shaped figure here, and this other circle. You want to describe the transformation in words and then show the transformation algebraically. Pre-image, and I should have said image. Pre-image, image. And you are going to construct 6 to 10 such panels with your partner or by yourself. That concludes this video.